Today we shall discuss the image formed by the thin convex lens, and we will derive this equation, that is minus 1 upon u plus 1 upon v is equal to n to 1 minus 1 into bracket 1 upon r1 minus 1 upon r2. Okay, it is minus 1 upon r2. Now see, here the figure is given how the image is formed by the double convex lens, means it has two convex surfaces. Okay, the image formation is seen here. First of all, we take the first surface of the lens. As you know, the convex lens is of this particular shape. So we take the first surface. First surface means this surface we take, and what happens if there is only one surface? Then here this is the object O which is kept, okay. Then this object distance OB will be U, and this is the incident ray, okay. Here the center of curvature for this particular surface. This dotted line shows the perpendicular drawn at a point of incidence. The light ray will be refracted and it will go in this direction, and its image is formed if there would be the medium of this refractive index, that is N2. Try to understand, if the medium this side is made up of a denser medium, say for example the whole medium, this surface is only present, then the image would have been obtained at this point, that is I1 according to last theory. This is incident ray, this is refracted ray, and this is another ray. Two rays will meet here and its image is formed here at this point I1. This is the medium whose refractive index is N2. Say for example, as you know, the lens is made up of glass, then this whole medium is of glass. If there would be only one medium, and we imagine that there is only one medium which is made up of glass, this is the medium which is made up of glass whose refractive index is N2, then the image will be formed here. Okay, if the medium would have been made up of glass, then the image would have been obtained here at this point I1. Okay, so for this situation, the equation which we have derived, the rays are going from rarer to denser medium, then the equation which we have last time derived can be written in this way. Okay, there must be minus, okay, this is minus n1 upon OB, that is object distance, plus n2 upon BI1, where BI1 is the image distance. You can see in the figure, BI1 is image distance, okay, image distance, that is the image which is formed by the first surface. So that BI1 is the image distance, okay, and n2 minus n1 upon BC1. Now you can see BC1 is the radius of curvature R1 for the first surface. Try to understand again. Here you can see everything is understood with the help of figure only. See, this OB is the object distance, okay, that is OB. Then BI1 is the image distance. So if you want to write the equation which we have derived last time, then that is minus n1 upon OB plus n2 upon BI1, okay, and it will be equal to n2 minus n1 upon r. Here it will be r1, that is radius of curvature for this particular surface, and that is radius of curvature which is, we can say it is BC. So it is written here as BC. In place of r1 we shall put afterwards. Okay, so it is written as BC1, or because this is the first center of curvature for the first surface of the lens, so it is written as BC1. Okay, you can see in this that is instead of R1, okay, it is written as BC1, you can see here, okay, and this equation is written according to the last theory, okay. Here there must be minus. If you are putting minus in the beginning, try to understand this part. If you are putting minus here in the beginning, then we need not to take OB is equal to minus u. Then you do not take OB is equal to minus u. If you are not putting, try to understand minus in the beginning, then whenever you put OB, then you have to take it as negative u, because sign conventions are already taken when this equation was derived, okay. Right now we place minus, okay, then at the time of placing OB as u, we will not put OB is equal to minus u, we will directly take OB is equal to u, okay. Then similar thing can be understood for the second surface. Lens has two surfaces. First surface we have understood, now we talk about the second surface. Now the light ray will go from this denser medium to this outer medium, that is rarer medium. So this will be the incident ray, okay, which is as such the rays are moving, we can say, from denser medium to rarer medium. If there would be a denser medium, then I1 behaves as virtual object. Try to understand. The image which is formed here by the first surface, that is I1, will behave as a virtual object for the second surface. So we can say the last image is formed here, that is at I. Okay, so this dI1, try to understand, this dI1 will become the object distance and dI becomes the image distance. So we write the formula as here it is taken, see, minus, okay. So minus n2 upon dI1, try to understand why minus, because it is there in the formula, okay, and the rays are moving from denser medium to rarer medium, therefore we have taken n2 first. Here in the beginning the rays were moving from rarer medium to denser medium, therefore n1 was taken first, so minus was kept by us, okay. So initially it was from rarer to denser, now it is going from denser to rarer. That is why first we have put this n2, and according to our equation we have kept the negative sign also. Here also we have to put negative sign, okay. So try to understand now this, okay, minus n2 upon dI1. Now why dI1 we have taken? Because dI1 is the object distance, okay. So I am writing that equation, minus n2 upon dI1 plus, now the rays are moving from denser to rarer, so n1 upon final image distance, that is dI, okay, minus n2 upon dI1 plus n1 upon dI is equal to, now that n2 minus n1 earlier we have written, now it will become n1 minus n2. Try to understand, everything will be reversed, and instead of n2 minus n1 we shall write n1 minus n2 upon radius of curvature, okay, and radius of curvature for the second is, we can say, dC2, or it is say R2, we can say, okay. So dC2 we have to write, it is written here dC2, okay. So you can see that equation here, okay, minus n2 upon dI1 plus n1 upon dI is equal to n1 minus n2. I have changed it, okay. It is taken as, because the rays are going from the denser to rarer. Okay, if they are going from rarer to denser, then it is n2 minus n1. If they are going from denser to rarer, then it is n1 minus n2. So it has to be changed to n1 minus n2 upon dc2. Okay. Now, as you see, bi1 and di1. Okay, bi1 and di1, they are same because we have taken this is a thin lens. Now try to understand, this is ABC, that is first surface, and the another surface is ADC. Now you take bi1 or di1, it will be same only because this is a thin lens. So either you measure the distance of this I1 from first surface, that is either from ABC surface or the another surface, that is ADC surface. Okay, this distance will be same only because this is a very small distance, that is this is a very thin lens. Okay, so bi1 and di1 both are approximately same, so we write bi1 is equal to di1. Okay, so it is written as bi1 is equal to di1, and we add these two equations. Mind well, this is negative. Okay, this is negative, and this we have taken as n1 minus n2 upon dc2. Okay, so by considering this, if you just add, then this n2 upon bi1 and this n2 upon di1 both will be cancelled out because bi1 and di1 are same, so they will be cancelled out. So you will have minus n1 upon OB, okay, plus n1 upon di plus n1 upon di. You will have n1 upon di. Okay, left hand side, try to understand this left hand side. When you add 1 and 2, this is negative. Okay, n1 upon OB is negative. This is n1 minus n2. So if you add this 1 and 2, what will happen? What will happen? This n2 upon bi1 and n2 upon di1 will be cancelled out because bi1 and di1 are same. So these two terms are same only. So they are cancelled out. Now what is remaining? The remaining part is minus n1 upon OB plus n1 upon di. So it is minus n1 upon OB plus n1 upon di. This way you can write. And on left hand side, it will be n2 minus n1 upon bc1 plus, okay, plus the other one, that is n1 minus n2. Try to understand, n1 minus n2 upon dc2. Now minus sign is taken common from this. So this positive will become negative. So our equation will become, it will become minus n1 upon OB minus n1 upon OB plus n1 upon di. Okay, and n2 minus n1 will be common, so it becomes n2 minus n1. Okay, and into bracket you will have 1 upon bc1. Instead of this positive, there will be negative minus dc 1 upon dc2. Sorry, it will be 1 upon dc2. Okay, so we can write it as 1 upon, okay, 1 upon dc2. Okay, so this equation will be obtained but with some changes. This will be minus n1 upon OB plus di n1 upon di, that is equal to n2 minus n1 1 upon bc1 minus 1 upon dc2. Okay. Now when the object is at infinity, then this OB will become infinity. Okay, this is negative. Again I am reminding you, OB is the infinity, then the image will be formed on the focus. So instead of di we write f. So minus n1 upon infinity plus n2 upon f is equal to n2 minus n1. Here it will be minus again. Okay, bc1 1 upon bc1 minus 1 upon dc2. Okay, sign conventions are always taken already into consideration, so now no need to write the negative sign instead of dc2. Okay, earlier also I have explained this. Okay, we are taking into consideration, so at the time of placing the notations v, u and r, we will not place their signs. Okay, so it becomes, okay, you will have this 1 upon infinity, so it becomes 0. So you will have this as, again, see, n1 upon f is equal to minus n2. Okay, n1 upon f is equal to n2 minus n1 1 upon r1 minus 1 upon r2. This we don't have to consider sign when we are placing the notations. Here 1 upon infinity is taken to be 0. So we will have this equation 1 upon f is equal to n2 upon n1 minus 1 1 upon r1 minus 1 upon r2, and n2 upon n1 is nothing but refractive index of 2 with respect to 1, that is refractive index of glass with respect to air if both the side there is air medium. Okay, both the side there is air medium. Okay, so this equation which we have obtained, that we wanted to derive. Okay. Now equation for thin lens, the equation which we have derived last time is written here. Okay. Now instead of this, we are taking the n1 common. Okay, and this n1 is taken in the denominator, that way also we can understand. Okay, this n1 is taken in the denominator, this n1. Okay, so it becomes n2 upon n1, and n1 upon n1 will become 1, and rest of the thing will remain as it is. Okay, so you will have minus 1 upon u plus 1 upon v as n2 1 minus 1 into bracket 1 upon r1 minus 1 upon r2. Okay, now if u is equal to infinity, then the object is at infinity. Okay, then this 1 upon infinity will become 0, and image distance v will be equal to its focal length. So 1 upon f is equal to n2 1 minus 1 1 upon r1 minus 1 upon r2. This equation we have obtained. Okay, and if you compare this second equation and the first equation, okay, just we have to take the comparison. Then on the right hand side you can see this is same. Okay, so we can say 1 upon v minus 1 upon u is equal to 1 upon f, which is nothing but the length formula that you have studied already in your 10th standard also. Okay. Now there is more information about thin spherical lens, and we will have the image formation by it. Say for example, if the object is placed somewhere here on its principal axis, and after refraction the rays are becoming parallel to principal axis, then object is said to be placed on the first focus. Okay, and if opposite to it, if the rays after refraction are concentrated at one point, the parallel rays After refraction they are concentrated at one point, then this is called the principal focus. Similarly, for the convex as rather concave lens, okay, the rays which are parallel to principal axis, okay, what will happen to them? They will diverge, they will go away from each other, and if they are extended back, okay, then they will form the image on the same side of the object, which is a virtual image. Okay, this cannot be taken on the screen, and this point is called the focus of the concave lens. Okay, this you have already studied in your 10th standard. Okay, now there are types of images when the object is placed at different points. When the object is at infinity, then image is formed at the focus of the convex lens. Here we will talk about convex lens only because it gives you the real, or rather we can say the image obtained is real, that is obtained on the screen. Okay, that is why we will talk about the convex lens only. This kind of lens is convex lens and this kind of lens is a concave lens that we have studied. Rays parallel to principal axis coming from infinity will form the image on the focus. Okay, when the object is between 2f and infinity, or we can say away from 2f, okay, then what will happen? Its image will be formed between f and 2f, real and inverted, diminished image will be formed. Then similarly, if the object is on 2f, then its image will also be on 2f. It is on 2f. Okay, an image is on 2f, real, inverted, and of same size. Okay, if the object is between f and 2f, then its image will be beyond 2f. You can see this is also inverted, real, but the size is more than the object. It is enlarged image, we can say. When the object is at f, then its image will not be formed, rather we can say it will be formed at infinity. These rays will meet at infinity, we can say. This is a highly magnified image if it is obtained, and it is enlarged and inverted image. If the object is placed between pole and focus, or optical center of the lens and focus here, then the rays which are parallel will pass through focus, and the ray which is passing through optical center is then both are extended in backward direction, then they will form the image on the same side of the object, and it is enlarged image. Okay, this is the concept which is used in magnifying lens. Okay, then for concave, as you know, the rays parallel to principal axis will diverge. Okay, if they are extended in backward direction, then they will appear to meet at a point which is called the focus. Okay, virtual and point like image is formed. This will be the, as such it is the erect image. Then if the object is placed anywhere, okay, any distance on the axis, then the ray parallel to principal axis, after refraction they diverge. If you pass them, and they will pass through focus. Ray which is passing through optical center will go without refraction. If they are extended in backward direction, then they will form the image somewhere here, which is virtual and erect, and it will be a diminished image. Okay, so these are the different images which are formed by the convex and concave lens. Okay. Now we talk about the magnification. Okay, you try to understand these two figures which I have already explained in the last question. Here the object is placed between f and 2f, and its image is formed here. Okay, on the other side, or rather we can say the image is on right hand side for this convex lens. And for concave, the image is on the same side of the object. Okay. Now, for the first figure, you can see, first of all, the magnification is defined as height of image upon height of object. So, if you consider the image height A prime, B prime as H prime, and this height as H, then the ratio of H prime to H will give you the what you call it, magnification. Now if two triangles are taken ABP, okay, this triangle I am talking about, okay, two triangles we are considering, okay, first is ABP and the other one is A prime B prime P, that is this triangle, okay, they are as a similar triangle, okay, then AB upon A prime B prime, AB upon A prime B prime is equal to PB or rather BP upon PB prime, you can write, okay. Now AB is H, A prime B prime is H prime, okay, it is below the principal axis, so use sign convention, so it becomes minus H prime, this becomes minus U, that is object distance, and this will be the image distance, that is PB prime, and that will be positive V. So if you write those notations, okay, then you will get this H upon minus H prime is equal to minus U upon V, and if you just minus and minus will become plus, H upon H prime will be V upon U, or magnification M is equal to V upon U, that is equal to H prime upon H. Okay, so this is the equation for magnification, and magnification is negative for real image and positive for the virtual image. Okay. Now we talk about the power of lens. Now what is power of lens? Power of lens is measure of convergence or divergence which a lens introduces in the light falling on it. Now see, we try to understand this figure. Okay, a ray of light parallel to principal axis would be going in this direction if this lens would have absent, but now it is refracted. Okay, say at an angle, it is changing the direction by an angle delta, and as you know, these two rays are, yes, this line and this line are parallel. Okay, you can see these two lines to be parallel, so these are two alternate angle. So if this angle is delta, then this has to be delta. Okay, so it is shown here delta and delta. Okay, now take tan delta, it's very easy to understand. Tan delta is nothing but opposite upon adjacent, so H upon F, this is taken as H. If H is equal to 1, then tan delta will be 1 upon F. Take H is equal to 1, then we will have tan delta to be 1 upon F. Okay. Now if delta is very small, then tan delta is equivalent to delta, so delta is equal to 1 upon F, and this 1 upon F is known as power of lens. Okay. The SI unit, as you know, it is meter inverse. Okay, or it is known as diopter. Okay, so this delta which is obtained as 1 upon F is known as power, which is P. P is equal to inverse of focal length. Okay, SI unit is diopter, or 1 diopter is equal to 1 meter inverse. Okay, the power of lens of focal length of 1 meter is 1 diopter. If you take F is equal to 1 meter, then power will be 1, and that is nothing but 1 diopter or 1 meter inverse. Okay. Power of lens is negative for converging lens, and it will, power of lens is positive for the converging lens. Converging lens means the lens which is converging the light rays. Okay, that is a convex lens. Convex lens is a converging lens. So power of lens for converging lens will be positive, because focus or other focal length of convex lens will be positive. Okay, so power will also be positive for converging lens, that is the convex lens, and power of lens is negative for diverging lens. Okay, that is nothing but the lens which is a concave lens. એટલે એમ કહી શકાય કે for concave lens the power will be negative. Power of lens will be negative. Okay, thank you very much.